the values.
Any number before in V of t, yes, yes.
Yeah, okay.
Yes, any number before 2 to see the sign here, any number between 2 and 4 in V of t to find the sign of V of t, and any number between 4 and 6 to find the sign of V of t in here. I know that this is quadratic and it opens up, so this must be negative and this is positive. You don't have to think in those terms. This is the shortcut. Just plug in 1 and you will see you'll get positive. Plug in 3 and you see you'll get negative, and so on and so forth. There is no need for me on the test, and I want to emphasize, please do not write no solutions on test paper. I'm begging you. Do not write anything on the test paper. You can cross it out, you can check, you can do whatever. They will shred it and I will not get it. Do not write anything on your test paper. You can cross it out and say, I solved this, or whatever you want to do, but do not write your solutions on the test paper. The other thing I want to mention, please do not write on the side. Okay, do not write, as I mentioned, like this and then this and then this. It's difficult for me to read. And if you write on the side because it's scanned, I may lose part of your solutions. So make sure that you have your solutions in the center of the paper. Do not come up to the last. I know we want to use the last inch, but please don't. So make sure that you write your solutions clearly, step by step, so I can give the maximum number of points. That's all I care about, to give you the maximum number of points. Okay, then we are determining the acceleration. A of t here is 6t minus 18. When you set this equal to 0, you get t equals 3. Therefore, you have to put the 3 where it belongs. And you have to put 0 where it belongs. You have to find the sign of a of t. Plugging in a number, you know this is a linear function. It comes from negative, goes to positive. So it has to be negative here, and it has to be positive here. Oh, I wanted to mention, but I forgot. You do not need to write on the side, oh, this particle goes in the positive direction between 0 and 2. And it's very clear to me. And negative between 2 and 4, and then again positive. No, no, no. I see it. If you put it here, it's good enough for me. Now, the velocity and the acceleration, if they work in the same direction, then they push the particle. But if they work in the opposite directions, they decrease, the acceleration decreases the velocity of this. So the particle is slowing down. No, it's not going backwards, but it's slowing down instead of speeding up. So here you see one is positive and one is negative. So the particle is slowing down. Here both of them are negative. So what? But they're going in the same direction, so they are increasing the speed of the particle. So this particle is speeding up. Here again, the two forces are against each other, so it's slowing down. Here again, they're in the same direction, so it's speeding up. That's all we need to look at. And I was giving you that silly example. Maybe, I mean, it's not silly. I ride my bike, and let's say I can only do 7 miles per hour. But if there is a 3 mile per hour wind, then my combined speed is 10 because I get a push from the wind. But if I can only do 7 miles an hour, but I have a force against me of 3 miles per hour, 3 mile per hour wind, then my actual speed will be 4. Because if the maximum I can do is 7 and I have a force pushing me back by 3, then my actual speed will be 4. But if I have a backwind, then my actual speed will be 10. So it's the same thing here. When forces go against each other, the particle is slowing down. When forces are both in the same direction, it's speeding up. Opposite direction, slowing down. Same direction, speeding up. That's all basically you need to do on that problem. Is this better?
Yes, thank you.
Awesome. Sure, my pleasure. Now let's go back and see Maybe we want to do another approximation. Because we've done all these. We've done differentials and how to evaluate. Tell me if you want to see the discussion. We can do the discussion in a minute. The linear approximation we can, but let's do another approximation. Let's say what if I choose? I will let you choose. And this is in 3.10. And I will move to page 14. So let's choose an approximation. 1.999 to the fourth, 1 over 4.002. We already did this. The square root of 100.5, e to 0.1.
We could try cosine of 29 degrees.
Very good. Cosine 29 degrees. Excellent. I'm asked to approximate this. I'm looking at the time. It's okay. I'm good. I'm looking at the video. So I don't care what I have. I'm asked to approximate. I immediately write this. Now I don't care about this for a moment. And I know that this piece is f of x plus dx. I need to identify number 1, number 2, and number 3. Once I identify these, I'll fill this in and I'm done. So look at this and give us f of x, and then f prime of x, and then x, and then dx. Anyone?
Is f of x cosine?
Of course, there is nothing else. I don't see any other function. Perfect. So then f prime, you're going to say negative sine x. Perfect. Now I need to identify x.
29.
Careful. I have to have x and leave room for dx. If this is 29, dx cannot be 0. Cannot be 0. There must be an error.
30.
Yes. So then what is dx?
-1.
Negative 1 degree. Awesome. Now there is a problem. What is the problem? Not with this 30. There is a problem here. Please remember that dx cannot be in degrees. Must be in radians. So we have to immediately, not for the angle that I plug in a trig function. That is okay. It doesn't matter if I plug it in radians or degrees. The answer will be the same. But 1 degree cannot sit outside of a trig function. It has to be in radians. So please remember, very easy to remember this. You don't have to memorize anything. Just look at the unit circle again. You know that this is pi and this is also 180 degrees. So it means that 180 degrees equals pi. If I want 1 degree, what do I divide both sides by? No, I don't want 180, I want 1. What should I divide both sides by to get 1 degree?
180.
Yes. So this, please do not use it in degrees. Don't cross it out like that. I'm trying to make a point. This will be negative pi over 180. Please remember that. Now we have all pieces. I have this, I have this, I have this. That's all I needed. So now let's write it. So cosine 29 degrees is approximately f of x. This is f of x, and x is 30. Please plug in 30 in cosine. Plug in 30 in cosine. That's okay. If you remember, that is the square root of 3 over 2. Plus f prime. F prime is negative sine x. I'm going to copy negative. Please plug in 30 in sine x. 30 in sine x. What do we get? Sine 30. 1/2 with minus in front. And times dx. Here's dx. Another negative. So negative pi over 180. So then the answer is the square root of 3 plus, so this was, I need a 180 here. 180 the square root of 3 plus pi over 360. So I have to multiply these two and I get pi over 180 over 360. Pi over 360. The least common denominator is 360. I have to multiply this by 180. So 180 the square root of 3 plus pi over 360. It has to stay as is. Please do not approximate it. The problem will state clearly, do not approximate, leave it as a fraction. Now you can say, show me. Show me that cosine 29 and this gibberish is the same thing or close. It cannot be the same thing. It has to be close. And I will show you. But you have to be very careful how you plug it in. Very careful. Because now when I plug in cosine 29, this will be a tragedy. Why this will be a tragedy? Because my calculator is in radian mode. Okay? So if I make the error to say, oh, cosine 29, sure, no, why not? Why not? Ah, ha, ha, ha. It makes no sense. 29 degrees is in the first quadrant. Cosine cannot be negative in the first quadrant. But now, if I'm careful and correct and change it into degrees, that it will be a different story. So my cosine 29 is the correct answer of 0.8746. And now I'm checking my gibberish. But if I don't put correct parentheses, I'm in big trouble. The square root of 3. Make sure you come out of there, plus pi. Close the parenthesis and divide by 360. When I click enter, if I don't get close to this, then I'll say, oops. It has to be close to this. I don't know at what digit, but it has to be close to this. So I'm going to do it. Enter. And it's 1, 2, 3. The change is at the 4th digit. The 10,000th, right? So I know I'm correct. But I will not even write this because I'm interested in the correct answer, in the exact answer. This is not exact. This is exact. So be careful with these cosine functions, trig functions, what you plug in. It depends on the mode you are in. Okay? Because the calculator requires he's not smart enough, or he, whatever you want to call it, the calculator. Not smart enough. Doesn't know what you're thinking when what you're plugging in. So now I know that indeed cosine 29 is very close to whatever this is. If you want, we can copy it just to have it here. This was approximately 0.87475,205. Okay, where is my page with that list? So these are the approximations. Do you want to look at another linear approximation for the function? So these are approximations for errors, right?
I still have one question.
Yes.
Okay, just like, why did we go with 30 for x again?
Okay, very good. So let me go back to the previous lecture in which we said, because this is important, very good question, because we said that x is whatever, like
Your
30.
screen, Professor.
Oh, yeah,
Sorry,
yeah.
skip
Did I touch something? Oh, yeah,
So-
yeah. I'm sorry. Thank you. I was still sharing. Thank you. So we're looking at degree. So we're looking at cosine 29. So this is 29. Okay. So I'm looking at dx to be a small number. I don't know anything about 29. What I know is 30, right? I have no clue of what cosine 29 means, but we've known this like for years, what cosine 30 is. So this one I know is the square root of 3 over 2. But who cares about 29? I have no clue. So obviously, x has to be big and dx very small. What can it be if I'm talking about 29? It can only be 30 and negative 1.
Okay, could we do like a different example?
Of which type of problem?
The approximation.
Yeah, sure.
Yeah.
But I think we should choose another example, but we should just identify what we need and move on.
Yeah, I think that's fine.
So let's pick.
Could we do the 1.9?
Yes. Yes. So 31, we have 1.999 to the 4th power. So I'm asked to, let me start a new video here. No, I guess not, because we only have 1 more minute. So I will write right here, f of x plus f prime of x dx. Once I identified, so I know that this piece is f of x plus dx. So I need 1, I need 2, I need 3. So let's identify f of x and then find f prime immediately because I need it here. Let's identify x and dx. So what do you think f of x is?
X raised to the 4th.
Awesome. What do you think, so this would be 4x to the 3rd. What do you think x would be?
1.
2.
Yes. What do you think dx would be?
0, 0, 1.
Yes.
Wait.
Excellent.
0, negative. Yeah.
Yep, exactly. So this is the focus, and this is the tiny error. Nobody wants 1.999. Everybody wants 2. But there is a minor error of negative 0.001. So this piece is your dx. X to the 4th will be 2 to the 4th, which is 16. This will be 8 times 4, which is 32. So you're done. So 1.999 to the 4th power is approximately 16 plus 32 times negative 0.001. So that would be 16 minus 3 zeros, 0.032. So this is 15. So this is an 8. This is a 6, right? 8, 6, and this is 9. So then when we check, we have, let me clear all this. So we have 1.999 to the 4th power. And we have 15.968. 15.968 we got. So better than anything because dx is very small. So that's why they are so close, because dx is negative 0.001.